To add a junction box for a secondary feed to the recycling machine, there are several requirements that must be met. Firstly, the junction box must be appropriately sized. The junction box must be large enough to accommodate the number of wires and connectors required. For this circuit, a 12-inch by 12-inch by 8-inch junction box with at least 12 knockouts is recommended. Secondly, consider the type of enclosure. The junction box must be an M3R enclosure suitable for outdoor use. The junction box must have adequate knockouts for the incoming cable from the main distribution panel, the outgoing cable to the relocated safety switch, and any additional ground wires. All wire terminations within the junction box must be secured using approved connectors. The cable connecting the junction box to the relocated safety switch must be sized appropriately for the load. For a 200 amp circuit, number 4 AWG THHN or XHHW aluminum cables are required. Use type THHN or XHHW aluminum cables for installations in wet or dry locations. Allow sufficient cable length for the relocation of the safety switch. Install the grounding conductor, number 8 AWG copper or larger, from the junction box to the ground busbar in the main distribution panel. Ensure that all equipment connected to the junction box is properly grounded. Here's an overview of the installation procedure. 1. Install the junction box in a suitable location near the old safety switch location. 2. Disconnect power from the circuit. 3. Remove existing wires from the old safety switch location. 4. Install the new cables into the junction box and connect them to the appropriate wires from the main distribution panel. 5. Install the ground conductor and equipment grounding conductor. 6. Secure all wire connections using approved connectors. 7. Close the junction box cover and tighten the screws. Here are some important safety considerations. Ensure that all electrical work is performed by a qualified electrician. Follow all applicable electrical codes and standards. Verify that the new cables and junction box are properly sized and installed. Test the circuit to ensure proper operation before energizing the recycling machine. Selecting the correct size of the junction box is crucial for safety and compliance. The National Electrical Code, or NEC, provides guidelines for sizing junction boxes based on the number and size of conductors entering the box. Insufficient space can lead to overheating, insulation damage, and potential electrical hazards. Always refer to NEC section 314.16 for detailed box fill calculations. Choosing an M3R enclosure is essential when the junction box is exposed to the elements. NEMA ratings indicate the level of protection an enclosure provides against environmental factors such as rain, snow, and ice. An M3R enclosure is designed to prevent water from entering and causing corrosion or electrical faults. Consider the local climate and environmental conditions when selecting the appropriate NEMA rating for the junction box. Knockouts, or COs, are pre-cut holes in the junction box that allow cables and conduits to enter. Ensure the junction box has an adequate number of knockouts and that they are the correct size for the cables being used. Unused knockouts must be properly closed with appropriate plugs or covers to maintain the integrity of the enclosure and prevent the entry of moisture or debris. The type of wire connectors used within the junction box is critical for ensuring secure and reliable electrical connections. Use only connectors that are listed and labeled for the specific type and size of conductors being used. Common types of connectors include wire nuts, split bolt connectors, and terminal blocks. Always follow the manufacturer's instructions for proper installation and tightening torque. Selecting the correct wire size for the circuit is essential for preventing overheating and voltage drop. The NEC provides tables that specify the ampacity, or current carrying capacity, of conductors based on their size, insulation type, and installation method. For a 200 amp circuit, number 4 AWG aluminum conductors are typically required, but always consult the NEC and local electrical codes to verify the appropriate wire size for the specific application. THHN and XHHW are common types of insulation used for electrical conductors. THHN is suitable for dry and damp locations, while XHHW is suitable for wet and dry locations. Both types of insulation are heat resistant and provide good protection against abrasion and chemical exposure. Choose the appropriate insulation type based on the environmental conditions of the installation location. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit in the event of a ground fault. Install a grounding conductor from the junction box to the ground busbar in the main distribution panel, and ensure that all equipment connected to the junction box is properly grounded. Use only approved grounding connectors and hardware. When installing the junction box, choose a location that is accessible for future maintenance and repairs. Ensure that the junction box is securely mounted and supported to prevent strain on the conductors and connectors. Avoid locations where the junction box may be exposed to physical damage or excessive moisture. Before working on any electrical circuit, always disconnect power at the source. Use a voltage tester to verify that the circuit is energized before touching any wires or components. Follow lockout/tagout procedures to prevent accidental re-energization of the circuit while work is in progress. When making wire connections, ensure that the conductors are properly stripped and cleaned. Use a wire stripper to remove the insulation without damaging the conductor. Remove any corrosion or oxidation from the conductor using a wire brush or emery cloth. Apply an antioxidant compound to the conductor before making the connection to prevent future corrosion. After making all wire connections, carefully inspect them to ensure that they are secure and properly insulated. Tug on each wire to verify that it is securely held by the connector. Wrap all exposed connections with electrical tape to provide additional insulation and protection against moisture. Before closing the junction box cover, double-check all wiring connections and ensure that no wires are pinched or damaged. Verify that the grounding conductor is properly connected and that all equipment is properly grounded. Use a torque screwdriver to tighten the cover screws to the manufacturer's specified torque to ensure proper seal. After completing the installation, test the circuit to ensure proper operation before energizing the recycling machine. Use a multimeter to verify that the voltage and current are within acceptable limits. Check for any signs of overheating or arcing. If any problems are detected, immediately de-energize the circuit and troubleshoot the cause before proceeding. In addition to following the NEC and local electrical codes, it is important to adhere to industry best practices for electrical safety. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Work in a well-lit and ventilated area. Avoid working alone and always have a qualified electrician present to provide guidance and assistance. The selection of materials should be based on their suitability for the environment in which they will be used. For example, in corrosive environments, stainless steel or other corrosion-resistant materials may be necessary. Similarly, in high-temperature environments, heat-resistant materials should be used. Always consult with a qualified engineer or materials specialist to ensure that the materials selected are appropriate for the intended application. The proper installation of electrical components is essential for ensuring their safe and reliable operation. All electrical work should be performed by a qualified electrician in accordance with the NEC and local electrical codes. Before beginning any electrical work, always disconnect power to the circuit and verify that it is de-energized. Use appropriate tools and techniques to install electrical components, and follow the manufacturer's instructions carefully. After completing the installation, thoroughly inspect the work to ensure that it is safe and compliant with all applicable codes and standards. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical systems. Electrical equipment should be inspected regularly for signs of wear, damage, or corrosion. Loose connections should be tightened, and damaged components should be replaced promptly. Electrical systems should also be tested periodically to ensure that they are functioning properly. The frequency of maintenance should be based on the type of equipment, the operating environment, and the manufacturer's recommendation. The design of electrical systems should take into account the potential for future expansion or modification. Sufficient capacity should be provided to accommodate anticipated future loads, and the system should be designed in a way that allows for easy addition or removal of components. Consider the use of modular components and flexible wiring systems to facilitate future changes. It is important to keep accurate records of all electrical work that is performed. These records should include detailed information about the materials used, the installation procedures followed, and any tests that were performed. These records can be valuable for troubleshooting problems, planning future maintenance, and ensuring compliance with regulatory requirements. Proper documentation is essential for ensuring the long-term safety and reliability of electrical systems. Training is essential for all personnel who work with electrical systems. Electricians should receive comprehensive training in electrical theory, wiring techniques, and safety procedures. Other personnel who work with electrical equipment should receive training on the safe operation of the equipment and the hazards associated with electricity. Ongoing training is necessary to keep personnel up to date on the latest codes, standards, and best practices. The selection of electrical equipment should be based on its performance characteristics, reliability, and safety features. Choose equipment that is designed for the specific application and that meets or exceeds all applicable standards and codes. Consider the use of energy-efficient equipment to reduce operating costs and environmental impact. The location of electrical equipment should be carefully considered to minimize the risk of damage or injury. Equipment should be located in areas that are dry, well ventilated, and accessible for maintenance. Avoid locating equipment in areas where it could be exposed to physical damage, corrosive chemicals, or extreme temperatures. Electrical equipment should be protected from unauthorized access to prevent tampering or vandalism. Use locked enclosures or other security measures to restrict access to electrical equipment, especially in public areas. Post warning signs to alert people to the presence of electrical hazards. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock by detecting ground faults and interrupting the circuit. GFCIs should be installed in all areas where there is a risk of exposure to water, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are devices that protect against electrical fires by detecting arc faults and interrupting the circuit. FSIs should be installed in all branch circuits that supply power to living areas, such as bedrooms and living rooms. Surge protective devices, or SPDs, are devices that protect electrical equipment from damage caused by voltage surges. SPD should be installed at the service entrance and in sensitive electronic equipment. Voltage surges can be caused by lightning strikes, power grid switching, and other events. Harmonic filters are devices that reduce harmonic distortion in electrical systems. Harmonic distortion can cause overheating, equipment malfunction, and other problems. Harmonic filters should be installed in systems with nonlinear loads, such as variable frequency drives and electronic ballasts. Power factor correction capacitors are devices that improve the power factor of electrical systems. A low power factor can increase energy consumption and reduce system capacity. Power factor correction capacitors should be installed in systems with inductive loads such as motors and transformers. Emergency power systems are systems that provide backup power in the event of a power outage. Emergency power systems should be installed in critical facilities such as hospitals, data centers, and emergency response centers. Uninterruptible power supplies, or UPSs, are devices that provide continuous power to critical equipment in the event of a power outage. UPS should be installed on equipment that cannot tolerate even a brief interruption in power, such as computers, servers, and medical equipment. Proper labeling of electrical equipment is essential for safety and maintenance. All electrical equipment should be clearly labeled with its voltage, current, and other important information. Labeling should be durable and easy to read. The electrical system should be inspected periodically by a qualified electrician to ensure that it is safe and functioning properly. Inspections should include a visual examination of the equipment, testing of the circuits, and verification of the grounding system. Any deficiencies should be corrected promptly. The electrical system should be tested periodically to verify that it is functioning properly. Testing should include insulation resistance testing, ground impedance testing, and voltage and current measurements. Any problems should be corrected promptly. The grounding system is a critical component of the electrical system that provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and to energize the circuit in the event of a ground fault. The grounding system should be inspected and tested periodically to ensure that it is functioning properly. Overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from damage caused by overloads and short circuits. Overcurrent protection devices should be sized appropriately for the circuits they protect and should be tested periodically to ensure that they are functioning properly. Regular thermographic surveys can detect hotspots in electrical equipment, which can indicate loose connections, overloaded circuits, or other problems. Thermographic surveys should be performed by a qualified technician using an infrared camera. Before working on any electrical equipment, always de-energize the circuit and verify that it is de-energized using a voltage tester. Follow lockout/tagout procedures to prevent accidental re-energization of the circuit while work is in progress. Use only insulated tools when working on electrical equipment. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes. Never work on electrical equipment in wet or damp conditions. Be aware of the potential hazards of working with electricity and take precautions to avoid them. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform the work. The design of the electrical system should comply with all applicable codes and standards, including the NEC and local electrical codes. The electrical system should be designed to meet the specific needs of the facility it serves. The electrical system should be designed to be energy efficient. The electrical system should be designed to be reliable and easy to maintain.